Okay, we're going to have a little look now at some complementary, what's called complementary relationships. Complementary as in not you're looking very nice today, that sort of compliment. In mathematics, complementary means adds up or sums to, might be a smarter way of saying it, sums up to 90 degrees or sums to 90 degrees. Right, for interest, 180 degrees sums to 180 degrees, that's supplementary. So complementary, it sums to 90. So let's have we're looking for relationships that sum to 90. One or two other things as well, a few examples, and then we will be ready to go with exercise 16K. Okay, so let's have a look at these complementary relationships we're talking about, sine and cos they deal with. I'm gonna show you a couple of different ways. So I'm going to just look at a very simple situation here, right angle triangle. Right, here it is, 90 degrees there. If I call this angle here theta, then by angle sum of a triangle, this must be 90 minus theta over here. Okay, hopefully you agree with all that. Now if I just call these sides A, B, C, and then start to explore, say, sine theta. Let's have a look at sine theta, B over C. We all agree? But another B over C would be this cos of this angle, wouldn't it? Adjacent over hypotenuse. So cos of 90 minus theta is also equal to B over C. So therefore, can we deduce from that that sine of theta will equal cos of 90 minus theta? Yes, we can. So for example, all right, let's sine 20 will equal cos 70. So you see that complementary relationship is that we can interchange these for 10 and 80 and 5 and 85. So sine and cos have got that relationship. So sine theta equals cos 90 minus theta, and vice versa. We'll also get cos theta equal to sine 90 minus theta. Okay, so that's one result. That's the sort of the difference complementary result. We're going to also explore a 90 plus theta result. Let's have a look at that. In order to do that, we just need to have a little think about some symmetrical properties here. I'm going to try. So this is our sort of unit circle scenario. We've got ourselves. Right, let's have a look at this being angle theta. Then if we wanted to look at 90 plus theta, that would give us a 90 degree angle there, and that would be theta in there, and this angle all the way around to there is 90 plus theta. I need to note that there is 90 plus theta. Alright, and this is theta. So if we have a look at the x and y coordinates at this point here will be cos theta, or actually what I'll do, it's going to be cos theta sine theta, but actually what I'm going to do is I'm going to just create some sides here. So that we're going to call B, this length here we're going to call A, just from there to there. Okay, and how are they replicated over here? As that flips across there, then you might see that that will become B there, and this A turns into this length here. So if we have a look at the coordinates now of this point here, they will be the xy coordinates there, so that'll be AB. And then if we have a look at the xy coordinates at this point here, then we've got B, it's B, isn't it, for the x coordinates? So that's switched around. Or is it minus B? Sorry, minus B, because we're over this side, aren't we? So we're in negative x territory. Minus BA. Righto, so now let's also relate something back here to what we know about cos and sine, and that is cos of this angle equals the x coordinate here. So cos theta equals A, but A is also equal to sine of this angle here, 90 plus theta. So could we say that cos theta is equal to sine of 90 plus theta? You see that? Cos of this, which is A, sine of 90 plus theta, which is also A. They must be equal. All right, let's have a look at sine theta, which is B. Now, is that going to be equal to minus cos, being the x coordinate, of 90 plus theta? So that's quite a useful little result, and that'll the reverses of those work. So sine cos of 90 plus theta equals minus sine of theta. Yeah, you can switch those negative signs around. But this is going to be quite useful for us. So those two plus this sine theta equals cos 90 minus theta, they're going to be able to use those down the track, just in little bits and pieces that we're working on. So, all right, let's have a look at some examples then. Okay, first example, if sine theta is 0.3 and cos alpha, these are two different angles, is 0.8, let's find some values. So we're working with, firstly, this one here, this is alpha. This is pi on 2, so that's 90. Now, what's sine of 90 minus alpha? We know that sine 90 minus alpha, right, have a look here, sine 90 minus alpha is equal to cos alpha. Right, that's just equal to cos alpha, which is equal to 0.8. Right, that wasn't too tough, was it? So what about cos pi on 2 plus, right, so we're going to go with A there, B, cos, let's have a look at cos pi over 2 plus, okay, looking at the second one, cos of 90 plus theta. Now what's that equal to? Cos of 90 plus theta, here it is, it's equal to minus sine theta, and sine theta is 0.3, so that'll be minus 0.3. Okay, so we're just using straight from here. Okay, sine of minus theta, so for example C, sine of minus theta, let's have a look at this little minus theta guy that we're talking about in here. There it is, going that way. Okay, so that means, what's that mean? All stages central is negative, isn't it? Negative in this one. So we can relate it back to theta in the first quadrant by saying it's equal to minus sine of theta positive, and sine theta is 0.3, so this will be minus 0.3 also. Okay, one more example. Okay, let's have a look at this question here. Given that sine x is 3/5 and x lies between pi on 2 and pi, so let's just deal with that. What that means is that my angle is between 90 and 180, so it's in this quadrant here, and sine x is 3/5, so sine's positive there, but the other two, cos and tan, they're going to be negative there. All right. So what are cos x and tan x going to be equal to if sine x equals 3/5? Well, here's how to do this. I'm going to just take from that, I'm going to put a little visual together of this. I'm going to put x into a little triangle. Here we go. Put x in here and represent this visually in this triangle. So this 3/5 is sides of this right angle triangle. So sine is opposite over hypotenuse. So that's 3/5. So that's 25. Let's work out from Pythagoras what this side's got to be. 25. That's 9. So that's going to be 4, isn't it? Square root of 16. So I've now got all three sides sorted out. So what's cos x? Cos x is equal to, cos x equals 4/5. But we're in this quadrant. We're told, remember, we're in this quadrant here. So cos x will be equal to minus 4/5. Absolutely spot on. Okay, and tan x will be equal to 3/4, but again, it's negative in that quadrant. So tan x will be equal to minus 3/4. So from this information here, we had basically two sides of a right angle triangle. Get the third side. We can then work out the other ratios because we've got all three sides now, and also just taking this information here, what quadrant are we in? If we can therefore apply the correct sign. Okay, I think we're okay now for exercise 16K. We'll do that next lesson. See you then.